Chapter 13 is going to look at various aspects of statistics. So statistics is the science of planning studies and experiments, obtaining data, and then organizing, summarizing, presenting, analyzing, interpreting, and drawing conclusions based on the data. So not only is it the process of collecting that data, but then it is also what do we do with the data after we have our data. There are two types of statistics. There's descriptive statistics, and then there is inferential statistics. Descriptive statistics summarizes or describes relevant characteristics of the data. This is just the facts. And it describes data or the collection, organization, summarization, and presentation of the data using tables, graphs, and calculated quantities such as averages. When you hear about statistics, this is probably the stuff that you are thinking of. It's the graphs and the calculations for mean and median, standard deviation, those kinds of things. Inferential statistics, on the other hand, uses samples to make conclusions about the population, drawing inferences or conclusions. So we're taking what we've gathered and we are making conclusions about the entire population or drawing inferences based on the information that we got from our sample. Let's talk about a few things that we use when we are collecting data. So the first one is a population. The population is the complete collection of all individuals to be studied or all items of interest. So for example, if we wanted to talk about high school students and we wanted to say, how many hours a day do high school students spend studying for a test? Our whole population would be everybody in the world who is a high school student. A sample, on the other hand, is a sub-collection of members for the group. It's a smaller portion of the group. It's only some of the items that are in our entire population. So if we were talking about all high school students and we took a sample and we said we're going to make Burbank high school students our sample, we could then make inferences based on what we collect from our data at Burbank High School and infer information about our population, which is high school students overall. A census is a collection of data from every member in the population. When we have large populations that we are looking at, it's very difficult to take a census. It can be very costly and very time-consuming. Censuses don't happen all that often. However, if we were going to look at just the students who are in this class, we could easily take a census because our population is very small. And last but not least, we have data. Data is collections of observations. These can be information that we gather from people. For example, if we ask what your favorite color is, the observations are the responses that we get from the people. Or if we wanted to sit on a street corner and observe the colors of the cars that are driving by, those could also be our observations or our data. So example 1 just has us identify the data, the population, and the sample in each of the following studies. Our first one says a survey of 1,353 American households found that 18% of the households only own a computer. So we need to say what is the data, what's the population, and what is the sample. In this case, our population is American households. The data is the survey responses. And then the sample is the 1,353 households that were surveyed. Part B, a recent survey of 2,625 elementary school children found that 28% of the children could be classified as obese. Our population is elementary school children. The data is going to be children's weights. And our sample is 2,625 elementary school children. Part C, the shopping destination every sixth person entering the mall within a 3-hour period. I should say the shopping destination of every sixth person entering a mall within 3-hour period. So the population is mall shoppers for that specific mall. The data is going to be the shoppers' destinations. And the sample is every sixth person entering the mall in a 3-hour period. So now that we have an idea of population, sample, and data, we're going to look at different types of data and ways in which we can organize that data. There's 2 types of data that we study in statistics. There is quantitative data and qualitative data. Quantitative data consists of numbers representing counts or measurements. Some examples of quantitative data is going to be heights of individuals, weights, distance, test scores, ages, etc. And qualitative data consists of names or labels that are not numbers representing counts or measurements. We also call this non-numerical data. Some examples of non-numerical data or categorical qualitative data. Some examples of qualitative data would be things such as eye color, hair color, favorite type of movie, example number 2, determine whether the data below is qualitative or quantitative. The colors of automobiles on a used car lot. That data is named or labels. A color is a category. Therefore, this is qualitative data. The number of seats in a movie theater. The number of seats represents a count or a measure. This is quantitative data. The numbers on the jerseys of a girls' soccer team. These are numbers, but it's not quantitative data because the numbers do not represent counts or measurements. They're simply labels. So this is going to be qualitative data. The blood type of each student in your statistics class, those are categories, so it is qualitative data. And the amount of fat in grams in 4 cookies, that is numerical. It represents a count or a measure, so it is quantitative. Now we are going to look at how do we organize this data? We collect data, how do we organize it? So frequency distribution is one way that we can go about organizing our data. So frequency distribution shows how a data set is partitioned among all of several categories by listing all the categories along with the number of data values in each of the categories. A table that lists the distinctive data values along with their frequency is what is created. And we're going to go through an example that shows exactly what a frequency distribution is. Example number 3 down here says 25 Army inductees were given a blood test to determine their blood type. The data is given below. Construct a frequency distribution and a relative frequency distribution for this data. Right now, we're just going to construct the frequency distribution, and then we will talk about a relative frequency distribution. We have a table. It's going to have 2 columns. One column is going to be whatever we are studying. In this case, what we're studying is blood types. And then the other column is going to be our frequency, or how often that item occurs. The blood types that we have are A, B, O, and AB. So all we need to do is count up how many of each type we have. For blood type A, we would count all of the A's. 1, 2, 3, 4. There are 5 of them. For the B's, we would count them up. There happens to be 7. O's, there are 9. And AB, there are 4. A relative frequency distribution, our vocabulary word happens to be on the next page. So a relative frequency distribution is the fraction or percentage of the data set represented. If n denotes the total number of items and given item, x occurred f times, then the relative frequency of x is f over n. Really, it's what percentage of the whole. But we want to find the fraction of the values for relative frequency. For our blood type data, our table remains the same. We're still going to have two columns. The first column is going to have blood type, and the second column this time is going to have relative frequency. And our relative frequency is the frequency divided by the total. They told us that there were 25 Army inductees. And we found our frequency for A was 5. This will be 5 out of 25, or as a decimal, 0.2. B, 7 out of 25, or as a decimal, 0.28. For O, 9 out of 25, which is 0.36. And AB, 4 out of 25, or 0.16. So the difference between a frequency and distribution and a relative frequency distribution just looks at proportions or percentages. And a relative frequency distribution is slightly easier to understand. We can look at this and say there's 20% have blood type A, 28% have blood type B, 36% have blood type O. We can easily quickly see what percentage. The other nice thing about relative frequency distributions is that if you have two data sets, the way that we can compare two data sets if they don't have the same amount of items in them is by using relative frequencies. Now we're going to look at grouped frequency distributions. That previous one wasn't a grouped frequency distribution. There was only one item within each, what they call class within a frequency distribution. However, a grouped frequency distribution, if we have data that covers a wide range, we might want to have more than one item that will fit into each class. So it's a frequency distribution for data sets containing large numbers of items in which the items are arranged into groups or classes. Within this, we need to look at a couple of other concepts. Lower class limits. So the lower class limits are the smallest numbers that can belong to different classes. Upper class limits are going to be the largest numbers that can belong to each different class. And this will make sense when we actually go through and create a grouped frequency distribution. Class width. The class width is the difference between two consecutive lower class limits or two consecutive upper class limits. So notice it is lower class limit to lower class limit, or upper class limit to upper class limit. Class boundaries are the numbers used to separate the classes, but without the gaps that are created by the class limits. There's a note down here that says class boundaries are halfway between an upper class limit and the next class's lower class limit. And then the last concept here, or last vocab for this part, is class midpoints. They are the values that are in the middle of the classes. And we will talk about how we find all of these. Some guidelines for making grouped frequency distributions. We need to make sure that each data item fits into one and only one class. We don't want any classes that overlap. The second thing, we want to try to make all of the classes the same width. Make sure that the classes do not overlap. There is an exception. The exception is if you have open-ended classes. For example, an age class, that would be like 54 and above. So that is the reason why we could have classes that also have different widths. We want to use between 5 and 12 classes total, and the classes have to be continuous. Even if there are no values within a class, we have to include that class within our frequency distribution. All of this will make a whole lot more sense when we actually go through and do an example. So that's what we're going to do right now.